Let's look at a baseline 2-wide in-order superscalar. That's a mouthful to say. So difference than the pipelines we've seen before, we have 2 ALUs. It's a big difference. We can execute 2 integer ops at the same time in this pipe. Drawn here, we're going to actually differentiate these 2 pipes. We're going to call this pipeline A and this pipeline B. And pipeline A, let's say, can do integer ops and branches. And pipeline B can do integer ops and memory access. But you can't do memory up here and you can't do branches down there. There's nothing fundamental. We're just going to look at this sort of basic example here to have 2 asymmetric pipelines. An important point of this, first, is that compared to our 5-stage MIPS processor, is that we have to be able to fetch 2 instructions at the same time. If we're going to want to actually be able to execute 2 things, we need to somehow get that out of the instruction cache or the instruction memory. OK, well, that's interesting. So the program counter is going to sort of go in here, and instead of getting 1 instruction out, we actually get 2 to go in these 2 different instruction registers. We also need to add more ports to our register file. Instead of, in our basic pipeline that we had talked about earlier, we had only 2 read ports. You gave 2 different addresses, and it outputted 2 registers. Now, because we have 2 different instructions going at the same time, we actually have to pull out 4 different read ports, or 4 different read registers at the same time. And if we want to be able to retire or commit instructions 2 at a time, we need to add more write ports. So I show the register file here sort of split into 2, but the register file is kind of, it's together, but logically I just drew it apart so you could actually make heads or tails of the drawing. So that's something interesting to think about, is you have to worry about that. OK, so the first question I have here, is this good enough? Is this pipeline diagram good enough in, let's say, the fetch stage? We stick some addresses in, we get 2 instructions out. So that's a good question, is do we do PC and PC plus 4? So let's say there's some logic here which can pull out PC and PC plus 4 at the same time, because we're executing 2 instructions. So roughly, we need to worry about alignment issues here. We need to worry about branches in, let's say, the first instruction that we pull out of the 2 instructions. In this next part here, our pipes are not symmetric. So is this good enough? So what happens if the first instruction that comes out here is a load? So instruction IR0 here, the instruction register, gets loaded with the bits from the load. What happens downstream here? Can the load happen here? Yeah, that's a problem. So we're starting to go to the superscalar here. We need to start thinking about having, we'll flip back and forth here and take a look at this. You need something here that can take an instruction that show up here and route all the operand values down over here. Largely, a lot of times people call this issue logic or instruction steering logic. So you have to sort of steer the operands, and you can basically swap the two instructions that are going down the pipe at the same time. OK, so that's interesting, and this is could actually cost some time to do this. So this might motivate us to have longer pipelines, and we'll talk about that in a second. Another thing you have to do is on the control side is you have to actually start thinking about duplicating control. So here we actually have to have 2 decoders because we're decoding 2 instructions at the same time. So the instruction register wires up to decode A, and this instruction register wires up to decode B. And then they're going to drive signals down across the respective A and B data paths. So that's something not drawn here is you may also, if you have to interchange the sort of instruction register 0 to the B pipe, you might have to, or you're definitely going to have some communication or some swapping of the instruction inputs here. So that's sort of the baseline to a processor.